All right, so we're going to talk a little bit about dimensional analysis. This is one of the things that I find to be extremely important, and I usually give all of my students this as the number one advice I can give you for getting good at physics, is being very good with knowing what units you have and also manipulating those units, deriving out units and what they're supposed to be. It's a skill that will really help you go a lot further in physics and pretty much all your sciences, because it can pretty much tell you immediately if you were wrong, and it's going to always also help you make any corrections to something you may not remember entirely. Maybe you're looking at the equation F equals ma, but you remember that it was F equals m over a, and if you know dimensions, then you can check it and realize you're wrong, and then even know what corrections to make. So dimensional analysis, this is just basically just messing with units and making sure you get them right. So a couple of things that go with this. First off, you can only add like dimension to like dimensions. You can't add things that have different units. Right down to, you're not really going to add kilometers and centimeters. You're going to want to convert them first. But for the most part, they have to have the same dimension. It wouldn't make a lot of sense to add 5 years and 54 grams. That doesn't really make sense. So whenever you are adding or subtracting, you have to make sure your units subtracting. Your units must match. Okay, they must match. But when you're doing multiplication or dividing, your units don't have to match. They don't have to match. Units not match. That's a good enough sentence, right? So your units, they just don't have to match there. So here they must, or you can't add or subtract them. Here they don't have to. When they don't match and you're multiplying and dividing, you're going to end up with usually some sort of derived unit, which we talked about, I think, in another video, which we'll get to there. So the basic rule of thumb here is you treat these like variables. If I had some sort of equation and it had x squared over x in it, I would simply divide x squared by x, and I would cancel one of them out, and it would just equal x. Well, the units on your numbers will work the same way. If I have meters squared over meters, then one of the meters in the bottom will cancel with one on the top, and this will just be meters. So it's a good idea whenever you're doing any kind of problem to carry these units along, and you basically combine them just like you would x's and y's and z's in algebra. So you could have something like 5 kilograms times 4 meters, and then divided by 2 seconds. And you would look at this, and none of these match, but ultimately you would just multiply the numbers together. 5 times 4, 20, divided by 2, you get 10. And then your units would just be kilograms times meters, and then per or divided by a second. All right? And then you would, after you did this, you'd check and see if anything was canceling out, and you'd cancel out. Otherwise, you would just leave it. Just like if it had been 5x 4y over 2z, you would just keep the x times y over top of z. So there's not a whole lot more to it than that. Just be sure to keep in mind that you're going to treat these dimensions like units, and you're going to always make sure before you add and subtract that the units match. And before you multiply divide, it doesn't really matter if they add or if they match or not, but then you're going to have to do some combinations where you're actually going to multiply and cancel out, or just combine units the way that it is written.